Hello, Hornets, and welcome. Today we're going to be talking about the alternating series test, and frankly, this is one of our easiest tests that we have. It has only two conditions that we work with. The first is that the nth term test works. After all, that's the first test we have, so we always have to check. Does the limit as n approaches infinity for the rule a sub n go to zero? The second is, does it alternate in sign? Does it flip-flop between positive to negative, positive to negative? And that's what we're looking for. Now, if I can demonstrate that a sub n for the rule, the as limit as n approaches infinity for my rule, a sub n, and if that's true, and I have an alternating series where the sign flops between positive, negative, the series automatically converges. So how is the series not going to converge? It's not going to converge assuming the nth term test fails. Now we do have to be careful because we can have different forms of a negative one. For example, I could work with the alternating series, and let's just say I have the summation. I'm going to zoom in on this. N equals 1 to infinity. This is what we're going to look at. Zoom in on it. Hope you didn't get too dizzy there. And I'm going to look at negative 1 to the n plus 1 divided by n plus 1. Now, in this problem, we've seen these before, but never with the negative 1 to the n plus 1 power. That is what's causing it to oscillate between positive and negative. Since we're talking about discrete values, where n is going to be a 1, 2, 3, 4, then my power for negative 1 is going to be a 1, 2, 3, 4, etc. When I have an even power of negative 1, the sign is positive. When I have an odd power of negative 1, the sign is negative. Now, in this situation, you'll notice we have an OP here, a P series, where P is equal to 1 right now. Now, if I take my limit as n approaches infinity, we're going to be doing the absolute value. So that's important to remember. We're taking the absolute value of that rule, which drops the negative 1 to the n plus 1. And now when I do this, it's pretty clear that I go to 0. That's the first test that we always do. The second test is, do I have an alternating series? Yes or no? Yes. The series, as n starts at 1 to infinity, for negative 1 to the n plus 1 over n plus 1 is an alternating series. Therefore, this must converge. Notice, it just has two pieces. Either my limit will go to 0 or won't go to 0. If it goes to 0, I look to see if it's an alternating series. If it is, we have convergence. If it isn't, I have to go to one of the other tests. Is it geometric, where the ratio is less than 1? Is it a P series, where P is greater than 1? Or perhaps it's an OP, where P is less than 1 but greater than 0. All of this information is necessary for us to then determine, do we have a convergence? So notice, in this one, I have an alternating series, and the absolute value of a sub n goes to 0. It converges by the alternating series test. That is what the alternating series test does. It's very straightforward. Let's take a look at another one. Let's look at this one. I have the summation, and I'm going to have n that's going to start at n equals 1, and it's going to infinity, and I'm looking at negative 1 to the n plus 1 times n squared divided by n squared plus 5. Now you'll notice the first test that we're going to do is the limit as n approaches infinity for the absolute value of negative 1 to the n plus 1 times n squared divided by n squared plus 5. Now, normally I wouldn't write the negative 1 to the n plus 1 because the absolute values take care of it. I'm putting in the absolute values and I'm showing you what I'm doing so that you can see. That means that this is really the limit as n approaches infinity for n squared over n squared plus 5. And our limit at infinity is 1. Since this does not equal 0 for the limit at infinity, the series has to diverge. And I don't even get to the point where I can check, is it an alternating series? Divergent is now what I have. Divergent. That's what we're doing for the alternating series test. It is very straightforward. It does not have anything difficult to it. You check to see, does the rule a sub n's absolute value go to 0? Yes or no? If it does, then I want you to look at it and ask, is it an alternating series? Yes or no? All righty. Thank you, Hornets. That's what I have for you today, and I hope this has helped with the alternating series test. Please beware, the next video that I will be talking to you about is the alternating series error and alternating series error bound. Furthermore, in class, I'll be giving you even more information about this and what's actually happening. Thank you very much. Be well and be safe, and I hope you watch the next video that will make this a little bit more clear. Please be well, be safe, and take care. And thank you for watching. Bye-bye, everybody.